In the diagram, D, E and F are 3 points in the Cartesian plane where angle E is 90 degrees as indicated on the drawing, and DAX is theta as we've got it there. Now the first question we need to look at is determine the gradient of DE. So we'll just do the following with the standard equation of a gradient, y2 minus y1 divided by x2 minus x1, where we can then, for instance, just say that D is x1 and y1 and E is x2 and y2. So we'll have minus 2 minus 4 divided by 2 minus minus 2. That will then give us minus 6 over 4 is equal to minus 3 over 2. So that is then the gradient of DE. Moving on to question number B. Determine the magnitude of theta rounded to 2 decimal digits. Now we know that there's a formula that says tan of theta is equal to the gradient, and we know that the gradient we've just calculated as minus 3 over 2. So we're going to say tan theta is equal to minus 3 over 2, and then just do the following operation. Second function tan, so it's tan to the power of minus 1 on your calculator of minus 3 over 2, and you'll get an answer of minus 56,3099 degrees. Now obviously that doesn't sound right. You can look at the drawing and you can see that theta is an acute obtuse angle. It's definitely not smaller than 90, and we're now getting minus 56,3 degrees. So what you need to know is that you've actually now calculated that angle there between the x-axis and going towards point E. That's the negative angle that you've calculated. Obviously theta would just be 180 minus that, so we've got theta is equal to minus 56.3099 plus 180 is equal to 123,69 degrees, and they said round off to 2 decimal digits, which we've done. So the magnitude of theta then is 123,69 degrees. Question number C. Show that K, now K is the y coordinate of point F down at the bottom here. Show that K is equal to minus 4. Now the way we need to do that is to get the equation of line FE. Now we know that the gradient of FE will be the gradient of what was it, DE divided by 1 divided by, it's actually 1 divided by the gradient of DE, or in another way of saying, it's just that gradient there, change the sign so it becomes plus, and swap those two numbers around, so it becomes plus 2 over 3. So that is the gradient of FE, and we know that the equation is y equals mx plus c, whereas m is 2 over 3. So y is equal to 2 over 3x plus c. Now we just need to determine the value of c as well, and for that we need an x and a y value, which is given by point E, 2 and minus 2. So minus 2 is equal to 2 over 3 times by 2 plus c. Minus 2 is equal to 4 over 3 plus c. Multiply right through by 3. We've got minus 6 is equal to 4 plus 3c. Take that 4 across and we'll have c. 3c is actually minus 10, so c is minus 10 over 3, and the equation then of the line would be y equals to 2 over 3x minus 10 over 3. That then is the equation of line FE, and then we know something about the point F. We know its x value is minus 1, so we can substitute the x value with minus 1 to determine the y value, which is what we're ultimately looking for, the value of k. So we've got 2 over 3 times by the x value of k is minus 1, minus 10 over 3 that will give us minus 2 over 3 minus 10 over 3 is equal to minus 12 over 3 is equal to minus 4, and that then is the value of k is minus 4, which is what we had to prove. Then they say, hence determine the coordinates of m, the midpoint of FE. Now the midpoint formula is given by x1 plus x2 over 2 and y1 plus y2 over 2. Then looking at the midpoint of FE, x would be minus 1 plus 2 over 2, y would be minus 4 minus 2, minus 4 minus 2 over 2. That will then give us a half, and minus 6 over 2 is minus 3. So the midpoint of that line would then be at a half and minus 3. That's for that question. For question number E, determine the equation of the straight line parallel to DE and passing through M. Now we know that the gradient of DE is given by minus 3 over 2. So the line parallel to DE would be given by y equals minus 3 over 2 x plus c. And we also know that it's going through the midpoint of M there, which is the point that we worked out just before. And we also know that the coordinates of that are half and minus 3. So we've got x and y values to substitute. So the y value would be minus 3 then, is equal to minus 3 over 2. The x value would be a half, plus c, so minus 3 is equal to minus 3 over 4 plus c, and c would therefore be equal to minus 2 and a quarter. If you take that minus 3 and a quarter across to the other side, you'll have a value of minus 2 and a quarter. So the equation of the straight line would then be given by y equals to minus 3 over 2x minus 2 and a quarter. That would then be the answer to that question. And then lastly, determine the area of triangle DEF. Now the area of a triangle is given by a half base times by the perpendicular height. Now if we for instance then take FE as the base, we'll have a half times by FE would be given by x1 plus, it's actually minus x2 squared plus y1 minus y2 squared, and the perpendicular height would also be given by the same formula, x1 minus x2 squared plus y1 minus y2 squared. And let's then substitute for the base of the triangle. We'll have minus 1 and 2, so it's minus 1 minus 2 squared plus y1 minus y2 minus 4 minus minus 2 minus 4 minus minus 2 squared. That is then for the base. The height is given by DE. Again it would for instance be minus 2 minus 2 for the x values, plus, and the y values would give me 4 minus minus 2 that's also squared, so this is a half. This will give me 3 squared is 9 plus minus 4 plus 2 ultimately gives me 2 squared, then 4. This bracket will have 4 16 plus 36. This would be a half times by 13 times by, obviously the distance, almost forgot that the distance formula has got to have the square root on top of it, don't forget that. So it's going to be all with it until the end. So it's still going to be square root 13, and that will then be square root of 52. And then if you calculate that, say half times by square root of 13 times by square root of 52, get an answer of 13 units squared is the area of that triangle DEF.